Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of inverse trigonometric functions, and we are taking this question from year 2023 of GEE mains. So if I talk about the question which is given to us here, the question tells us that S is a set where x belongs to real numbers and it satisfies the function which is given to us as sine inverse of x plus 1 upon square root of x square plus 2x plus 2 minus sine inverse of x upon square root of x square plus 1 is equal to pi by 4. So this is our entire expression given to us in the set S. And then we have to figure out what are the values of x which satisfy this expression. And when these values satisfy the expression for the values of set x, we need to find out summation of x belongs to all the values of set S with the expression that sine of x square plus x plus 5 with pi by 2 minus cos of x square plus x plus 5 with pi. So we have been asked to find the value of this entire expression with the sum of all the values of x which belong to this set x. So first of all, let's find the values of x which belong to set S. Once we get the values of x, we'll just substitute those values here and find the sum of the entire expression that is asked to us. There are four options also given to us for this value of the expression of the question asked. That is 0, 1, 4 and the last option 8. So we need to figure out which is the correct answer for the expression given to us. Let's figure out first of all the given data. We have been given the expression sine inverse of x plus 1 upon square root of x square plus 2x plus 2 minus sine inverse of x upon square root of x square plus 1 is equal to pi by 4. Now you can solve this question with two methods, but I'll try to show the easier method to solve the question. This looks like a very difficult question, but if you get the first step correct, then you can easily solve the entire question. So if I try to first of all solve this part of the expression, sine inverse of x plus 1, I can write this entire thing in the terms of a perfect square as a square plus 2ab plus b square. So I need plus 1 here. So I can split this plus 2 as plus 1 plus 1. So x square plus 2x plus 1, this is your perfect square. And you are left with 1 minus sine inverse of x upon square root of, again I can write that as x square plus 1 square equal to pi by 4. Sine inverse of x plus 1 upon, I can just write that as square root of a square plus 2ab plus b square, that is a plus b the whole square, and this is 1 which is 1 square sine inverse of x upon square root of x square plus 1 square. Now once I am simplifying this idea, now we just need to focus on this. Let's say this entire expression is nothing but a and this entire expression is equal to b. So if I just use the idea of right angle triangle to denote my trigonometric ratios, first let's say talk about a sine inverse of x plus 1 upon square root of x plus 1 the whole square plus 1 square is equal to a. From here I understand x plus 1 upon square root of x plus 1 the whole square plus 1 square is equal to sine of a. Sine of a we already know it is nothing but opposite upon hypotenuse. So when I have this, that's why trying to frame my hypotenuse in terms of opposite side. So let's say my angle is A. This is your opposite side x plus 1. This is your hypotenuse, which is square root of x plus 1 the whole square plus 1 square. So if I figure out this side, it is given by base square, or base if I want to find out here, and that is given by, if I use the Pythagoras theorem, we know perpendicular square plus base square is equal to hypotenuse square. So base square becomes hypotenuse square minus perpendicular square. So base square, if I try to find out, it is hypotenuse square minus perpendicular square. So this gets cancelled, you are left with base is equal to 1. So you get this side also, that is equal to 1. Once you have this, you can write it in terms of tan. So tan of A, if I try to figure out, which is opposite upon adjacent side, get that as x plus 1 upon 1. So I get A turning out to become tan inverse of x plus 1. So I get A in terms of tan inverse. Now again we'll try to get the other B also in terms of tan inverse. So if I solve for that as well, now we have substituted sine inverse of x upon square root of x square plus 1 square is equal to B. So from here I get x upon square root of x square plus 1 square is equal to sine B. We already know again sine B is nothing but opposite upon hypotenuse. So if I draw another right angle triangle, this angle is B. Opposite side is x. Hypotenuse is square root of x square plus 1. Now once I have x square plus 1 square, again if I try to find the base, that is given by perpendicular square plus b square is hypotenuse square. So base square is hypotenuse square, x square plus 1. Perpendicular square, which is x square. Again you get base as 1. Once you get the idea for base again as 1, you can again find the tan theta with that. Tan of B is equal to opposite upon adjacent, which is x upon 1, which is equal to x. So from here I get B also in terms of tan, that is tan in terms of x. So once I had this equation with me, this entire equation which was, once I substituted that as A and B, I got A minus B is equal to pi by 4. So if I try to just reframe my equation, now we already know A is tan inverse of x plus 1. B is tan inverse of x is equal to pi. Now if I just use the idea, we know tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y upon 1 plus xy. So if I just use the idea here, I get this becomes tan inverse of x minus y upon 1 plus x into y is equal to pi. So from here I understand this x and x gets cancelled out. After cancelling x, what we are left with, let's write that down. So you are left with tan inverse of 1 upon 1 plus, if I multiply that, you get x square plus x is equal to pi by 4. If I take tan on the other side, it gets 1 upon x square plus x plus 1 is equal to tan of pi by 4, and tan of pi by 4 we know it is equal to 1. So 1 is equal to, I take this entire expression on the other side, becomes x square plus x plus 1. So 1 is equal to x square plus x plus 1 plus 1, if it goes on the other side, becomes minus 1 and 0. So x square plus x equal to 0. From this, if I further solve this expression, x taken common, I get x plus 1 equal to 0. That gives me x is equal to 0, or x plus 1 is equal to 0, which is x equal to minus 1. So solving this set S, we understand it gives me two values of x, that is 0, minus 1. So if I just put the values of x as 0 and minus 1 in the entire expression, and if I take the sum of both the expressions, once solved, let's see what I get. So if I have that entire expression with me, where it is telling me summation of x belongs to all the values of set S, and the expression given to me was sine of x square plus x plus 5 pi by 2 minus cos of x square plus x plus 5 into pi. So if I try to put both the values, first let's put x equal to 0. That makes it sine of 5 pi by 2, because 0 and 0, 0, plus 5 minus cos of again 5 pi, plus, if I put x as -1, that gives you -1 square, that is 1. 1 and -1 again becomes 0. 0 plus 5, again you get sine of 5 pi by 2, minus, you again get cos of 1 and -1 again makes it 0, so 0 plus 5, you get again 5. So sine of 5 pi by 2 is nothing but, I can understand it, 0, pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, this is 5 pi by 2. So sine of pi by 2 is same as sine of pi by 2. So sine of pi by 2, we know it is always 1. Here also you get that as always 1. Minus, let's find out cos of 5 pi. So cos of 5 pi, if I try to find out 0, get pi, 2 pi, 3 pi, 4 pi, 5 pi. So cos pi and cos 5 pi are same as it is. So cos pi is -1. Here also you get that's -1. So you get this 1 minus -1, 2. 1 minus 1, 1 minus -1 again 2. So 2 plus 2 gives you answer as 4. So we get the correct answer for this entire expression which is asked to us, and that comes out to become 4. And if you see, the option that matches here with the question is option C. So C is the correct answer for the question which is given to us here, that we have been asked to find the sum of the entire expression for all the values of x, and that comes out to become 4. So C is the correct answer. I hope you have understood how to solve this type of question. So the main component in this difficult question was to convert this entire question of sine inverse in terms of tan inverse. Once you got that understanding, you can just solve this question very easy. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains as well as 11th and 12th. So stay tuned for more videos to roll out. Also, do like, share and subscribe to my channel. Do share those videos with your friends also who are involved in this preparation, so they can also take the benefit from these questions which we are solving every day. Thank you.